I've had a few questions about how to do truth tables and how to do homework 21. So what I have here is I just recorded myself doing it, and I'm just walking through the process. So I did all of the first six, and then I did an indirect truth table. So for the first five, the first one really is an easy one because all you have to do is plug in the truth tables that I gave you, and then just look at the truth tables in the truth table charts that I gave you before in the lecture notes and just plug and play. It's really nice and easy. But it gets more difficult with number 2 because number 2 has Q, and you don't have a truth value for Q. So figuring out what that truth value is just a little bit more complicated. What I did here, as you can see, is that I just went through what both options would look like if Q were true versus if Q were false. It doesn't even really matter which one it is, because either way, false and anything ends up with false, therefore it ends up false. And the same thing happened on number 3, as you can see me doing here. So it's easy to get caught up on not knowing that truth value, and I get feeling like, oh my god, I can't do this because I don't know that truth value, but really it's not so bad if you just take a step back and think about the project, think about the problem as a whole, and just what would the consequence be regardless of whether or not it's true or false. It gets a little easier that way. I hope that makes sense, at least. 4 and 5 were, again, they were just plug and play, nice and easy, and this is the process that you'll do inside of truth tables for each box in a truth table on the right side of the truth table, which we're going to show in just a second once I finish this one. I am not doing this voiceover as I am doing this. I actually recorded this and now I'm doing the voiceover afterwards, so that's why it's not exactly timed properly. So for number 6 is the first one, we have a truth table. Notice the instructions. You have to have a complete truth table, not just an indirect truth table. So we have to build the full truth table, including all of the lines with each of the variables. So I have gone in and put in a dividing line between the variable sections and then the actual argument section, proposition section, just to make it really clear where those divide, because sometimes arguments will just have like a variable, which makes it a little more complicated. Now, these truth tables get really clunky really fast, and in the lecture notes I showed you how to like divide up the problem, but that's not the way I was trained to do it. Actually, that's something that was in a textbook that I thought some people might find useful, but other people might find that even clunkier and even more problematic. So what I did for this truth table was I just plug and played for every box and basically solved this truth table the exact same way that I solved the first 5 problems in the homework assignment. But the first thing you have to do is set up your variables. Remember, you start from the right, true, false, true, false, true, false, all the way down. The next one's true, true, false, false, and then the next column is true, 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 false, 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 false. And it just keeps doubling every single time. So if there was a 4th variable column, it would have been 8 truths and then 8 falses. Now, for solving the problem, what I did here is I just copy and pasted all the way down, and replaced Q as I went, the first variable in our line, with its respective truth value, because Q is nice and easy, 4 truths and then 4 falses. I always start with that one. And then I did R, so you can see here I'm just replacing it with its truth value according to the variable tables, and then I'll move on to S after that, so makes it nice and easy. I tend to do my truth tables this way. You do not have to. You can go box by box individually, but I mean, this is faster, so that's why I do it this way. That's why I do all the replacements first and then solve it piece by piece through the whole thing first, one at a time, as you're going to see in a second. Alright, now we're ready to start solving. Now that we've replaced all those variables. We're just going to do one part of the problem at a time, one part of the proposition at a time. Give us some space. And then one little chunk at a time. Remember to always start from the inside of parentheses. So you want to start with the most interior piece of the line possible every time that you do one of these propositions. It just makes it easier that way. I just copy and pasted it, and then I grabbed the most interior piece, solved that, and then repeated the process for the entire line. And as you can see, when you're doing these, it's really not that different than what we did in 1 through 5. It's just that you're doing it repeatedly, using different truth values for each one. And the reason why you're doing that is because you don't have universally the truth values for the entire proposition. You have no idea what the truth values are, so you're testing all possibilities. That's what truth tables do. They test all possibilities for all truth values throughout a line. So it makes it a little bit easier to figure out what the possibilities are. It does give you a complete table. The problem with truth tables, really, the reason why they're annoying and why most students hate them, is because they take forever. You know, if you've got 4 or 5, variables, that is a lot of lines of truth table to do. And that's why today, Monday, when this video is going up, I'm covering how to do indirect truth tables, because it's a shortcut and it's a lot easier to deal with in the field whenever you're like actually doing this as a philosopher, as a logician. Indirect truth tables are so much better because they save you so much time. These truth tables can get really, really big. I've seen 60 some odd line truth tables before. They're massive and they're annoying and nobody likes to do them. So the last problem on this homework assignment was actually a really big truth table, and I did not want to do that. I actually only did one truth table here. I only did number 6. I did not do any of the other truth tables because they just take so long. And once you've seen one, I mean, it's not hard to figure out what to do with the others. I think the problem that a lot of students have figuring out how to do truth tables is that they're not looking at the what do they call, operator truth tables that I gave you in the previous lecture notes. You know, the and truth table, the or truth table, the if then truth table. And if you're not looking at those and you're trying to do this like from memory or something, or if you're trying to memorize those, that's not gonna work. Old school logicians, old school logic teachers used to require you to memorize those truth tables. That's ridiculous. You don't need to do that. You're never gonna have to have that memorized. So just have it in front of you and just check every single time. That's what I do. I mean, I've been doing this for years and I still double check myself every single time of what causes it to be true, what causes it to be false. Just go line by line, item by item, one piece at a time of the problem, and you will get to the answer slowly but surely. You just have to slow down and do it right, rather than trying to speed through this. Yeah, it's going to take a while, but you will get the right answer if you're just methodical about it. Alright, coming up on the end of each of these now. We're getting the main operator of this entire proposition is the not. So the last line to be solved on all these boxes will be the not line. And thankfully they made it nice and easy because it's the first one's not true, and then every line after that is not false. So it makes it nice and easy and quick to solve these going through. It's always the same. And there you have it. That is the completed truth table. That's how you go through it. I purposefully picked a big one to do for it. That is a complete truth table there. And now I'm going to show you how to do an indirect truth table. Now, indirect truth tables work best with propositions, which is why I'm going to show you how to do it with a proposition rather than showing you how to do it with a regular one of these from the homework. I'm going to actually pick one from a textbook and show you how to do it with a proposition instead. But the process in its pieces is the same. You start by building your table itself. You put in your variable columns. You have to have all of your variable columns please, please, please always try to put these in alphabetical order, because it makes it so much easier for me to grade if you do it that way. So putting in the variables here, and then we're going in and putting in the argument piece by piece. Just typing this in from my textbook. Bam. So there's our argument that we've got, and we're going to use an indirect truth table to solve this. Remember what the point of indirect truth tables is, like how it works. You want all of your premises to be true and your conclusion to be false. That is an invalid argument. That's the definition of an invalid argument, right? A truth table that has true premises and a false conclusion. So we're trying to force it to be invalid. We're trying to create an invalid argument on purpose is what we're trying to do. And if we can't, then it's a valid argument because it doesn't have that line. The way the indirect truth tables work, basically at their core, is just to try to create one line of a truth table that is invalid. So we're going to start with the easiest premise, which is that not our premise, and turn that into a true, which means not false, which means that R was false. And we do the same thing with the next premise over, right? We have R, so now we figure out the next variable. And then we use the same process for the first premise, and we figure out all three of our premises, and we get true on all of them. Remember, you're just using those truth tables to do this. Those operator truth tables to do this, to figure this out. Once you have all true premises, you can try to force the conclusion to be false, and the way you do that is by testing the truth values of the premises that you found, of the variables that you found. So you found the truth values now for all three of those variables. You're going to plug them into conclusion, and fingers crossed you're going to get a false. So we're just plug and play. You'll notice basically indirect truth tables is just working backwards. That's all it is. You're just working from the truth value you want and working your way backwards instead of working forwards. And sure enough, we get false. So it's an invalid argument, just like we wanted. And that's how you do indirect truth tables.